Okay, welcome to subtopic 6.3 electrochemistry in topic 6 redox reactions. In this video, I'd like to cover the electrochemical reactions that which is what involve a flow of electrons during a chemical reaction. I want to establish what the galvanic cell is and what the components are. So, to establish what electrochemistry is and what galvanic cells do, let's just look at the definition, which is it is a study of the interaction between electrical and chemical energy in a chemical reaction. So if you have got chemicals, you can then convert chemical energy into electrical energy, and if you apply some electrical energy, you can cause some chemical reaction to store that energy. So yeah, electrochemistry is to do with energy transfer. Galvanic cells, they convert chemical energy into electricity. So think of the things that can do that. A spontaneous reaction that occurs as soon as the circuit is complete, that generates the electrical circuit. And on your right, you see a diagram that shows what the galvanic cell can look like, and you'll be making them. So in this example, you've got zinc as anode and copper as cathode. Now, let's look at the components. Now, because you need to be able to make them, it's better for you to know what's involved in that. So firstly, you've got two half cells. And half cells contain, well, firstly the container, you'll be using beaker for most of the time in a laboratory setup. And you've got metal electrodes. So again, in this diagram, you've got zinc electrode, and a copper metal. Could be a strip, could be a rod. And you've got salt solution or electrolyte. In this electrolyte, what you have to make sure is that you have got the same element as ion floating around as the metal electrodes. So if you use zinc electrodes, you have to use a solution of zinc, say zinc sulfate. So zinc 2+ is floating around. Likewise for copper side, if you have got copper, then you have to have copper ions floating around in that electrolyte. Otherwise, surprise, surprise, metal displacement can happen. You can connect those two half cells with connecting wire, and in the middle you can have voltmeter, multimeter, or some sort of load like LED lights or a light globe, buzzer, whatever is fine, that can consume electricity. And to complete the circuit, so from one cell to load and then to another cell, you have to connect that in between place with what's called salt bridge. So it's a bridge made with salt solution. So usually what you can do is to just grab a piece of filter paper and soak that in a non-reactive electrolyte. You might be using potassium nitrate because that's known to be non-reactive. That doesn't add anything to the reaction, redox reaction that can occur in the solution. Again, you've got diagram there. Anode is sending electrons to cathode, and that defines where is negative electrode and positive electrode, or what's anode and what's being cathode. More reactive metals lose electrons to the ones that are less reactive. So reactive ones are oxidized. You need to be able to work this out looking at the metal activity series. So if you compare zinc and copper, zinc is much higher in reactivity and copper is much less. So zinc could be sending its electron to copper ions. So copper would be reduced. Sorry. Okay. So oxidation that always occur at anode. Oxidation is anode. Here's a mnemonic: A for anode, N for negatively charged, because that's where the electrons come from. Write that down, by the way. And O for oxidation occur. A and O for anode. Anode, negative, oxidation. Therefore, the other side must be reduction side, and that is called cathode. Now, cathode is also where cations go as well. Anode is where anions get attracted to as well. Okay. So that's something also for you to note down. Wire connecting electrodes, it allows the electrons to pass through. And salt bridge, so that's an electrolytic conductor. It allows the ions to flow, because one side will be more negative, one side will be more positive. So the positive side would attract negatively charged ions, and if a number of positively charged particles on one side gets consumed, then need to put a bit more positiveness. So that's what happens to each side. We will be watching this video of how we can make galvanic cell or battery with coins. Alright, so in a typical galvanic cell, I'll just zoom into this one. You've got zinc solid becoming zinc ion. That's what's written in here. Observation you might have is that the zinc metal would corrode, and zinc ion concentration goes, what do you think? Well, it's corroding, so it goes up, increases. As explanation, well, because zinc is more reactive compared to copper, you would see zinc becoming zinc ion. Then that releases 2 electrons, and you can see that that's oxidation. Oxidation happens at anode. Where electrons come from is considered to be negatively charged side. On the other hand, contains less reactive metal. Half cell that contains less reactive metal would experience Cu2+ ion becoming Cu solid. Observations you would have would be copper solid develops on the electrode, or might be sinking at the bottom. And because you're working with copper ions being consumed, blue color will become paler. So the solution would become clearer. Explanation wise, well, Cu2+ gains 2 electrons and it becomes Cu solid. So that's the solid you would see, and blue color being consumed. Reduction always occurs at cathode, and electrons are consumed, therefore it's considered to be positive end. Now, this is an example which I'll cover in the next video. So what you need to be able to do is going to be to draw and explain in terms of which way electrons go, what ions would be consumed, or what metal is being consumed, and what half equation can be written, as well as the overall, as usual.